Well, so far we have actually created two types of filter. First we saw there are four types of filter. There are other special types of filter, but basically I have low pass filter, high pass filter that we have already seen. Now let's start with our third one, that is our band pass filter. Okay, so band pass filter, if you actually remember what I actually told you, is that the concept was like this. I have this portion and this portion. Okay, I have three frequency component like this. I have three frequency components. So I want this middle portion. Okay, I want this middle portion. That means I want to crop this one out, also crop this one out. Okay, I want only this portion. Okay, to get that, I want to pass allow this portion. This is my allowable frequency range, and I want to crop this one. I also want to crop this one. So I want to pass this portion. That's why it is called band pass filter. Now how we can do that? Okay, the concept is not actually very difficult. So let's understand the concept first. So say first, okay, this is my frequency. Okay, first let's design a high pass filter. If we design, so the high pass filter actually kind of looks like this. It kind of looks like this. This is my high pass filter portion, right? So say I have a high pass filter first. Okay, high pass filter, sorry about the writing. Now then high pass filter, then after high pass filter, if we cascade a low pass filter with that, first a high pass filter, then we cascade a low pass filter, the output of the low pass filter, is somewhat like this. Okay, now if we cascade these two portion, okay, if we cascade this portion, then I will have something like a output like this. Okay, we'll have an output like this portion and this portion. Okay, okay, like this portion and this portion will have something like this. So this is my, again, 3 decibel point. This is my FL and this is my FH. I said before we have two cutoff frequency. One is the low frequency side and one is the one in the high frequency side. And the middle between that we have, this is what we call the bandwidth. Okay, the bandwidth of my band pass filter. So my bandwidth of my band pass filter is my high frequency FH minus my low frequency. Okay, okay, and this is my portion. This is the pass band. This is my stop band. This is my stop band, and only this is my pass band. So this is my band pass filter. Okay, so let's actually do this using our PSpice. Okay, okay. So again, go to File, get a new project. So this is my BPF1. Okay, BPF hierarchical project. Okay, okay. Now don't worry about the PSpice design. It is actually very simple if you know what to do. Okay, so first we have to design a high pass filter. So I have VSC, place my input. Then for a high pass filter I need to place capacitor here. Okay, then I need to place my resistor here. Okay, just rotate it. So I have this high pass filter. Now let's connect this portion. Simply connect them. Okay, so everything is okay. I have to place the ground. Don't forget to place the ground. It will show automatically generate an error. Okay, so I have the ground. Another thing is that I want to change this volt value to say 0.01 microfarad. Okay, so this is what I have. So let's place my first probe here, input probe, and my output probe. So then we can simulate it. It's my BPF1. Okay, so my BPF1. So I will do AC sweep. Okay, I believe you already understand this type of analysis. You are familiar with this, the other type of analysis. So let's start with the start frequency of 1 and make the end frequency 1 million. Okay, and points per decade is we are using logarithmic scale. You see, this is decade and this is octave. Okay, and previously I told you that there was 20 decibel per decade and 6 decibel per octave. And this is the scale of logarithmic scale. We'll discuss it later if we actually get some time. So this is my circuit and let's run it. So this is my high pass filter. Now what we want to do is to add a low pass filter along with it. Okay, so to add a low pass filter I need a capacitor, but the capacitor now goes here and I need another resistor. Okay, I need a resistor and resistor goes here. So this is the output of my high pass filter. Now to that output I connect a low pass filter portion. Okay, this is my low pass filter portion. Okay, then we connect a ground here. Okay, so we connect a ground. Now we see the output here. Okay, so this was my high pass filter portion and this is my low pass filter portion, and we are trying to see the output from here. Okay, so let's run it. So here we can see, let's increase the limit a little bit. So let's add another 0 here. Okay, then apply and okay, then run it. Okay, now as you can see, this was my high pass filter portion, but there was another one that was my low pass filter portion and it truncated, and totally we get this portion, and this is my band pass filter. Okay, this entire portion is my band pass filter. So from 70% like this one, so anything less than that is cut out, anything higher than that is cut out, and only it is this portion is allowed. Okay, so this is my pass band. Okay, so if we actually draw our circuit here also again, so to see, this was supposed to be my, okay, then I have this one. Okay, so yeah, this is my resistor. Okay, and this is my V input. Here I am providing my input signal. So this portion is my high pass filter. Then I connect my low pass filter here. Okay, this is my low pass filter here, and from here I am getting the output from here. Okay, so sorry about that. Okay, so here this portion was my high pass HP and this portion is my low pass. Okay, so the summation of them, okay, we cascaded two filters and we got our band pass filter. So band pass filter is actually, by cascading a low pass and high pass filter we get the band pass filter. Now the question is to you is that what is the order of this filter? Can you answer? Can you guess? Okay, here you can see, if you remember, the order of the filter depends on is actually the number of reactive components. Okay, now here I have one reactive component is capacitor, there is another reactive component here. So the order of this filter is n equals to 2. Okay, we cannot have n equals to first order band pass filter, we will always have a second order band pass filter. Okay, so this is my band pass filter design. Now there are still again the same issue that was with low pass filter or high pass filter. The same issue we'll also get here is that the first of all the straight cutoff, the cutoff frequency is a gradual cutoff. We can actually add, we can make it n equals to 2, we can make it 4 or 6 higher order filters to get much a straight line, a straight cutoff. Okay, sharp cut, we call it actually sharp cutoff. The other thing was the attenuation problem. Now to solve the attenuation problem, as you can see, after a high pass filter portion, my input signal will actually attenuate quite largely. Okay, then I am feeding it to my low pass filter, so there is a double attenuation of my signal. Okay, the input signal was already decreasing, now due to two filters it is decreasing much more. So when you are actually using a band pass filter, we actually normally have to use an op amp, okay, so that we can actually get an output signal that is good enough. Okay, So what we can do is that what we normally do, first of all, here in the middle, here you can see in here, before we actually feeding the output of my high pass filter to my low pass filter, we add an op-amp here. Okay, now we can actually normally add this op-amp as a buffer. Okay, you know buffer, the buffer operation. Let's write it down, let's make it problem. So buffer is that whatever the signal I have, I generate the signal with my amplification is equals to 1. Okay, now also we can actually add some amplification here as well, that will amplify my signal, that is also okay. So let's make it in our PSpice. Okay, so there we have my signal and my circuit, and here okay, in this middle, okay, in this portion I'm going to place my op-amp. Okay, let me do it. So I have placed my op-amp here like before, the way we actually placed before. This is my op-amp, so let's make it 15 volt. Okay, 15 volt positive. This is my 15 volt negative. Okay, 15 volt negative, ground. This is my feedback resistor, goes to my output, and this is my other resistor, input resistor. Now the output of my high pass, the output of my high pass filter, I will feed that output to my input of my non-inverting amplifier, and this is my output of the op-amp. Okay, and I will feed it to the input of my low pass filter. Okay, and then I'm getting the output from it again. Okay, now let's take a look at the output now. So as you can see, now this is my output. Now we have an amplification. Previously it was 1 volt. Since we have twice, so I have amplification like this. Okay, so we can actually this way we can actually create an active band pass filter. Okay, so I hope it is okay. Now there are other things, there are two things we actually already discussed here. One was my FL, that was my low frequency. One was my FH, that was my high frequency. That was my low frequency 70%, high frequency 70%. Now there is another one, that is what we call FR. Okay, FR is my what we call center frequency. Okay, center frequency. Now center frequency is actually here, this portion, in the middle portion. Okay, so 70%, this is my low frequency, this is my high frequency, and the center frequency is my FR. Okay, it is also known as resonance frequency. There is another name, resonant frequency. Okay, resonant frequency, and that is why it is actually denoted by FR. Now this FR, resonant frequency, is equals to actually FL multiple by হচ্ছে আমার FH, multiplied by my FH, and root over, okay, square root of FL into FH. And this has some importance. Okay, and this has some importance with the quality factor of my band pass filter. Now, and the term quality factor, okay, it is what we call a Q factor. Okay, Q factor, it is actually we are going to discuss this quality factor in the next video. Okay.